at you. And it looked like it wasn't really the calculus in these cases. There's a lot of the factoring and stuff. And that's why it's something we need to just go over just so it's kind of fresh, so you don't forget it. Same with the reference triangle, same with limits, same with all that other stuff. All right, you guys, take a look at your quiz 21. Now, a bunch of errors on this one. Again, one thing a lot of people were getting on like version 21, version A, you get like 6x squared plus 18x plus 12 is the derivative. And then you set it equal to 0. And then this is where it all started happening. What happened? But it's okay again. You guys, don't forget, you guys, just so you get stuck on this one quiz, it's not like, oh my god, I'm so embarrassed. I was just showing someone this week, one of the smartest people in one of my classes, how to do long division. What I'm saying is, like, don't, just because you're like, forgot how to do one thing, doesn't mean you're stupid or like, whatever. It just means you forgot how to do the one thing, and then you practice it. Oh yeah, now I remember again. Do you know what I'm saying, you guys? Don't ever feel inadequate about anything in this class. You guys are in AP Calculus. It's the hardest class there is. There's just so much to learn, as well as so much to review. It just takes sort of like a nice even keel. And don't forget that, Eric. Okay? So you get something like this, and this is where, like, man, the wheels are falling off on this quiz. What happens now? Some people actually factored it as is, which I think is pretty hard. What should we do here first? Take a 6 out. Boom. And it's going to happen, And that's why I'd rather now, on some silly little test, than on the test. And just practice, practice, practice. That's why I'm coming up. That's why I think it's important. Because what you can do then, you guys, is just divide both sides by 6. All legal operations. Only 0 divided by 6 is gone. And now, we play the factor game. Okay, what are two numbers that multiply to 2 and add to 3? 1 and 2. And again, you can't have any other number over there if you wanted to break these up. Because the only way, if it was like a 5 or something over here, then there's billions of combinations of numbers that would make that work. Where if this thing equals 0, well, either this thing has to equal 0 or this thing has to equal 0. And that's why the whole factoring game works. Only when it's a 0 over there. Okay? So then from here it's like, okay, how do you figure out if it's a min or max? Or any of that stuff? Well, what you can do is set up a side chart. If you have when the derivative equals 0, -2, -1 is my x values. Okay, what's the number left of -2? Jesus.
-3.
-3. Does that make this positive or negative?
That makes it negative.
What about this one?
That makes that negative.
So negative times a negative is a?
Positive.
Okay. Between -2 and -1, what's a nice number over there? Jesus, keep this going.
-2.5. I mean -1.5.
Okay, is this positive or negative?
Negative.
This one?
Positive.
Negative times a positive is a? Negative. What's a number to the right of -1? 0. Okay, which means the original function is increasing, decreasing, then increasing. Which makes this a max, and this a min. Now, the value is what I asked for, right, you guys? So this is where without a calculator, a lot of people, I think, just spent a lot of time and got super close to reality, super ridiculously close. I don't even know how you did that. I'm like super amazed. But it's just like not there. It's like just like a smidgen off with that cubic 1/3. Just a nightmare. Or if you want to know what the max value is, you say, okay, put -2 6, -2 squared plus 18, -2 plus 12. Max value of this at x equals -2, and you're done. Because that's a number. Do you know what I'm saying, you guys? And there's like 2 or 3 people like, I don't think they just left. It's like, leave it. Because if you don't have a calculator, like, things like this, if it's free response, this is perfectly acceptable because that's a number. Okay? Question?
Yeah, I think mixing up critical point and extreme value.
So extreme value is extreme. And what that means is extreme value is the y value. The value is the y value. Like intermediate value theorem means like, it means the y value. So we're going to answer in a second. And mean value theorem means like, you know, like the average value. Where critical point is where it occurs. Do you see the difference, you guys? Critical parts of the x value where the stuff's happening. The derivative is 0 undefined.
So a critical point could also be an inflection point, right?
Well, it happens to be so in certain cases, but you definitely just still have to take the second derivative, set that equal to 0 to solve for those. Okay?
So critical point is not necessarily
No.
an extreme value.
The only places an extreme value can occur are at the critical points and at endpoints.
Right.
The inflection points have nothing to do with it.
But could you have a critical point that isn't an extreme value?
No.
You could.
Oh, yes. Yeah, the flip you can't have.
Right, yeah.
But sure, yeah. Because, yeah, it could be that the second derivative is also equal to 0, and it just happens to be an inflection point. Yeah. But how you can test it, you check your critical points, you make your table, and where you see a change in sign, that's a min or a max. If you don't see, if this goes from positive to positive, then it's neither. It's not a min or a max. You have to see the change in sign. And another thing, just talking about that, you guys, about inflection points. The definition in the book is actually confusing. I was looking at it more and more, and a little more over this weekend. And really, to have an inflection point, you just need the function to exist at that x value, meaning it has to have a tangent line. And then you have to have a change in concavity. Which means is, I don't care what like the value of the x value is as far as second derivative and all that stuff. Wherever you see a change in concavity, meaning if it's undefined there, if it's equal to 0, anything like that. If you see a change in concavity, meaning the second derivative changes from positive to negative, and that point exists on the original function, that's an inflection point. Does that make sense? Yeah.
Does that mean when the second derivative is 0?
Which is what we usually see. Second derivative equals 0 is usually, okay, that's the point we check. But when we see things with graphs and things, and we're going to get to more of that later, like chapter 5, like we get to more stuff. Where you have an inflection point is where the second derivative changes sign. Okay? Or when the first derivative changes from increasing to decreasing.